Today we'll be looking at 2.8, which is fitting a model to data, part 2, and I'm going to show you some other ways of making things a little bit easier in Desmos, and we're going to do something called combined variation, which we've seen before. We just never used it with Desmos. So the question is, how do you create a combined variation equation using various data? So we're going to do one example, and that's it for the entire lesson. Example 1, consider the problem of determining the maximum weight that can be supported by a board. 3 quantities that influence the maximum weight m that a board can hold are the board's width, the thickness t, and the distance d between the supports. The goal is to find an equation relating WTD and the dependent variable m. Here we cannot use a single graph to determine the equation representing this situation because there are 4 variables. However, by keeping all but one independent variable constant, you can investigate separately the relationship between the dependent variable m and the independent variable, and that independent variable. So, for example, we have many different variables. We have the thickness, so this is for the thickness, t. And then we have the distance, d. That's how far apart the supports are, as you can see on here. And then we have a width of a board. So a lot of different factors. We have the thickness of the board, the width, how far apart the supports are, and the last thing we have is the maximum weight m. Max weight. So what we're doing here is we are going to be pushing down on a board, and we're seeing basically where the breaking point is. What's the maximum weight you can have on there when it breaks? But we can't do it with all these variables at once, so what we're going to do is just isolate them. We're going to do m with t, then we're going to do m with d, and then m with w. So we're just going to do one set at a time so we can use Desmos and figure out the relationship between each one. The first one we're going to do is m with w, the width. Part A. Perry worked on this problem and found the model by working with the variables 2 at a time, just like I said. First, Perry held the 2 independent variables d and t constant, so we're going to have a specific distance and specific thickness. He did this by placing supports at the end of a 12-foot long, 1.5-inch thick boards of different widths. So they're keeping the distance 12, and we're keeping the thickness 1.5 inches. We're going to be changing the width. He measured how much the weight of a board given width. He measured how much weight a board of a given width could support before it broke. He obtained the following data. So we're going to go ahead and graph these in Desmos. We have our x and y. So x is going to be the width of the board in inches. Our y is going to be our maximum weight. And then we're going to use Desmos to plot the points and figure out which variation equation should be used. And then I'm going to show you kind of like a faster way of doing this rather than trying to find k algebraically and all that. So let's see which one we need to get. So we'll go to Desmos. And we're going to add a table. So I got to type in my numbers. So I'm going to have 1, 2, 3, 4, 5, 6. And then 9, 18, 26, 36, 44, 53. So one thing you can do, instead of changing the x and y axes on here, like going through this wrench that we did before, is you can press this little magnifying glass over here, and it zoom fits to these data points. So you click on that, and it just takes us there. Gets us a nice scale for x and y. And so this time you can kind of see what it looks like. It looks like it's probably going to look like a straight line. So you have to figure out, well, which one of these equations is a straight line out of these 4 that we have, and that one happens to be y equals kx. So now we're going to go ahead and type in y equals kx on our second line. Add a slider. This is something we haven't done before when solving these, but we're just going to go ahead and slide this slider until we actually line up the points and see what value that would be. Looks like 8.9. We almost hit this one down here. It's hitting most of the other ones, so you have to do it like as best you can. So I'm going to use the value 8.9 as my k value. There you go, 8.9. What is the new variation equation using our k value, m and w? Oh yeah, I didn't even read part B. To verify we're correct, we're going to enter the equation into Desmos and bring up a slider for k. So it actually tells you exactly what to do. Find a reasonable k value. So our new equation actually is going to be m equals, because it's your y value, right? I'm just going to kind of combine these two things together to get our equation. So m equals our k, which is 8.9, times w, our width. And then we're going to use this to answer the question down below. What is the maximum observed weight of a board that has a width of 8.5 inches? So that means 8.5 is going to go in for w up here. So we have m equals 8.9 times 8.5. Go ahead and type that in. And I got 75.65. And the last thing is to confirm your point on Desmos to make sure it's right. So we're going to take our point w and our so our x and y value is 8.5 and our m value. So we're just going to go ahead and check and see, whoops, if 8.5 comma 75.65 is actually on our line that we just drew. So let me go back to that and add a new point, 8.5 and 75.65, and you should see the point appear. So if you go to 8.5, which is over here to the right, it should show up on our line, and it does. Okay, part B, excuse me. Perry then investigated the relationship between M and the board thickness T. So now we're talking about the maximum weight and the thickness. He held the distance D between the supports constant at 12 feet. Is that what we did last time? Yeah, we did 12 foot last time as well. And the width now is going to stay constant at 2 inches. So the W is now 2 inches. He varied the thickness, so we're changing the thickness, and measured the maximum weight that could be supported. The table below shows his findings. So we're going to do X and Y again, plot these points. X is T, and Y again is M. So it says use Desmos to plot the points. The same thing as before. We're going to figure out which one this actually works for. So let me move this over. We're going to get rid of the table and everything else we had. Start fresh. I just closed everything out. 1, 2, 3, 4, 5, 6. You should also be doing this with me to test and make sure it's right, so that you can do it yourself, because we will be doing a test on it where you're required to be able to use Desmos. So we're going to hit the plus sign here again and lines everything up. Hopefully you can see that this one's kind of curved, whereas it would come down and kind of get slow, like not as steep, and then it kind of comes down here. We can probably assume that it would do the same thing on this side. So which equation should we use? I don't think it's going to be this one. And then these ones have the branches. Just for an instance, I want to show you what they look like, right? Just so you remember. I'm going to make some very small graphs here. So this is the one that we kind of just did. Went like this. X squared is the parabola shape where it looks like this. K over X is a hyperbola. So it's kind of like this. You got your two branches that were opposite. And then K over X squared is something like this. Remember, these quadrants can change depending if they're positive or negative. So the one we're looking at, I think, is going to be K, or Y equals KX squared. So to verify we're correct, we're going to enter the equation to Desmos and bring up a slider like we did before. So Y equals KX squared. Add the slider. And we're going to go ahead and try to bring it up to those points. Let's see what we get. Looks like that's pretty good. That would be at the number 8 for K. So the value here is 8. What is the new variation equation using our K value? M and T. So M equals, remember that's the Y value that's up here. And then we have 8 times thickness T, and don't forget that's being squared. So I'm combining these two together and changing out Y and X for M and T. The last part, we're going to use this down here. What is the maximum observed weight of a board that has a thickness of 3.75 inches? That's going to be plugged in to T because it stands for thickness for T. So we'll have M equals 8 times 3.75 squared. Make sure you do the squared first. So it's 3.75 times another 3.75. I got like 14.0625. And I'm going to multiply that by 8. So I got 112.5. And I should be putting some units on these. This one's in pounds. Confirm your point on Desmos. So the point we just used was 3.75, comma 112.5. We're going to see if that works. Add a line in the table. 3.75, 112.5, and it's right there. So it shows up on our parabola. So we have one left to do. One last combination, part C. Next, Perry investigated the relationship between M and D by holding T and W constant. He chose boards of a 1.5 inch thickness. So this is your T. And 2 inches wide. That's W. Then he measured the maximum weight, again, that the boards of different lengths hold. So we're changing L. The boards of different lengths would hold. Perry obtained the following data. So we have distance D. This is going to be your X value now. Oh, sorry, not lengths. For L, length is distance. And then Y is our observed maximum weight. So again, same thing. Plot our points. So I'm going to delete these things here. And I think I can probably just delete these. We're still using 1, 2, 3, 4, 5, 6. But we're going to change these out. So we have 212, 106, 71, 53, 42, 35. And if you can tell, now we kind of got like this arc shape. And that should match up with two possibilities. It's either this one up here or this one up here, because they kind of have the same shape. It's just that the other branch of this is in different quadrants. So I'm going to test both of these at the same time. So on this side here, I'm going to go ahead and circle these two. I'm not sure exactly which one it is, right? But it's got to be one of these two. So if we aren't sure which variation equation you choose, try both possible equations to see which would work for this data set. We're going to try changing the k-value slider by clicking the number and entering in larger values. So let's put both of those in at the same time. New line, y equals kx, k over x. Add slider. And I'm going to use another one, y equals kx, k over x, and then hold shift 6, put a squared. So there's the two equations. We're trying to see which graph would line up with these curves here. So if you move the slider, now that we have k on both these equations, it's going to move both the graphs at the same time, if you see that. Okay, so the purple is 2 going up, and then we have a blue one going 1 down and 1 going up like that. So the problem is we can't actually reach out there far enough because it's not going out the whole way. So what we're going to do is we're going to click on either the -10 or the +10, and we're going to change the scale of this. So we know it's clearly out here pretty far. So I'm going to go ahead and change this from 0, the lowest we can go, up to, I mean, this is like up to 300, 400. Let's do 300. You could put whatever number you want in there. Our step is just how much it's going to go by. I'll go by ones. And now we have the scale up to 300. So as we slide it to the right, we can kind of see it's going to get closer and closer to lining up with the dots. And which one does it line up with? Probably right about there. You can see the blue one lines up perfectly, which is the one that has, or what's blue? You can look over here for the blue. Y equals k over x. So I don't think we need the purple one. I'm going to take that one out. And so, yeah, this lines up perfectly. So we're going to use y equals k over x. Which variation do we use in this situation? Y equals k over x. What is the new variation equation using our k value, m, and d? So now we're going to use, say, the maximum weight. Our k value, you can go back and look at it. We're going to use 212 over d, our distance. And then we'll use this to answer the final question here. What is the maximum observed weight of a board that is at a distance of 7.2 inches? That's your distance. We're going to plug it in. So we do m equals 212 divided by 7.2. Let's see what we get. I got 29.4 repeating. I'll just use 29.4. And so this would be in pounds again. Let's go ahead and check the point. So our point's going to be these two numbers combined. We have 7.2, comma, 29.4. Go ahead and go back to Desmos, make a new line. 7.2 inches, 29.4. And I think that's out here, if you can see it. And it shows up on our graph if you zoom in perfectly. And the last part, now we're going to combine all these together. Part D, what is the final formula using all variables m, w, t, and d? So I'm going to start making the equation. So this would actually be a new k value that we don't know. So I'm going to start m equals k. And then w, we're going to go back and find where we saw w, and that was the first one? Yeah, first one. So remember we had m equals 8.9 times w. So we're going to use this, k times w. So we know it's times w. Then we go back and find what t is, the relationship between that and m. And that was t squared with m. So times t squared. And then the last one, we had a k divided by d. And so we're going to have this all over the variable d. So this would actually be the combined variation. Which is what we wanted to do from the very beginning, was do combined variation. So we go back here, combined variation. And that's it. I know it took us quite a while, but we can't do all the variables at once. So we just start with m and put the relationship with w, see what that is, do it with t, and do it with d. So we had to make 3 different ones to see the relationship that m has with each individual variable. And that will wrap it up for chapter 2, where we're going to be using Desmos on the test and doing the same thing, plotting points and making the equations. But at least now you know how to do it a little bit easier with the slider.